Okay, so we found their common denominator. We eliminated what they had. You have to distribute the common denominator to each term, and each term is its own math problem. So now we're just going to collect like terms and go from there. So I'm going to have 4x squared minus 13x minus 12x, or 12, excuse me, equals 4x squared minus 16x. You want this to equal 0. We're subtracting 4x squared from both sides and adding 16x. So we can get this by itself. So we have 3x you know what, I have a misstep right here. This part right here, 16 and 16 is 32 plus 3 is going to be negative 29. That's what happened. Let's work that out. And then if I do this, I'm going to get negative 13x minus 12 equals 0. And then we're going to solve for x. We're adding 12 to both sides. Negative 13x equals 12. Divide both sides by negative 13. X equals 12/13. But you have to do a true or false for this. So the way that you do this is you're looking for a true so that we can say that that's a correct solution. So where x equals negative 12/13, we're going to substitute it back into the original problem. 4 times negative 12 over 13 plus 3 over 4 minus 4 times 12 over 13 negative over negative 12 over 13 minus 4 equals negative 12 over 13. Put that in the calculator. The left will equal the right. So this is a true solution. So you're going to check all solutions. To be x minus 5. So we're going to say x minus 5 times x over x minus 5 equals x minus 5 over x minus 5. You're distributing the common denominator to each term. So then we eliminate. And then we're going to be left with x equals 5 plus 5x minus 25. And so we have x equals 5x minus 20 minus x minus x. 0 equals 4x minus 20. When we factor this, it's going to be 4 times x minus 5. So then we're going to say 0 equals 4, 0 equals x minus 5, plus 5 to both sides, x equals 5. This is not a solution. This one is a possible solution, right? X equaling 5 is a possible solution. So now we have to test our solution. So when you do that, we're just going to say 5 over 5 minus 5 equals 5 over 5 minus 5 plus 5. So automatically this is undefined because you cannot have a 0 in the denominator. So in this case, your solution is the empty set. That's your answer. Same thing, our common denominator is x plus 2 and x minus 4. You always want to make sure that you FOIL them out. So just in case. These problems are pretty simple. We just have to be confident with our denominators, creating them. So now we eliminate. So after we do all that, let's see what we're left with. We're left with 16x minus 64 equals x squared minus 2x minus 8 plus 2x plus 4. Want to collect like terms. There's nothing we can do on the left, but we can do some math on the right. Let's see. We're going to have x squared plus 4. No, it's x squared minus 4. Thank you. So when minus 16x plus 64 plus 64. When there's nothing to combine, they just get written in order. So it's x squared minus 16x it's a minus plus 60. And then we have to factor this. So then I get x minus 10 x minus 6. 0 equals x minus 10. 0 equals x minus 6. So now you say 10 equals x. And then 6 equals x. So I have two possible solutions, right? So that's a possible solution. Then we got to check our math. Let's do the first one. We're looking for truth. Remember, we're checking our math. We're not creating new solutions. So for 10, and we're solving for x, 16 over 10 plus 2 equals 1 plus 2 over 10 minus 4. So in this case, we get 16/12 equals 16/12. So that's a solution. For the next one, we're checking for 6, right? 16 over 6 plus 2 equals 1 plus 2 over 6 minus 4. So in this case, we get 2 equals 2. So when the left equals the right, that's how we're getting the true or false. So we're determining that both of these are true. So your solution is going to be x equals 6, 10. We're working on the inverse operation. So remember, if this is a square root, the inverse of that is going to be a perfect square. And whatever you do to the left, you have to do to the right. So I'm going to square both sides. I'm going to get x plus 3 because it's just going to give you what's underneath here as the base. And then on the right-hand side, it's going to expand. And then we have to collect like terms and simplify. So we're solving for x's here. And we still have to check our solutions for true and false. So we want this to equal to 0. And then when we factor, that's when we are using the zero product property. So now we need to check our true or false. Let's try the 6 first. So this is going to be 6 plus 3 square root equals 6 minus 3. And they both equal 3. So that's good. That's true. And then true, false. The x equals 1. So this is going to be 1 plus 3, and then the square root equals 1 minus 3. This is 4 equals negative 2. 2 equals negative 2. This is false. So the only solution we have is x equals 6. Those are supposed to be like the set cube roots, but you have to have one on each side in order to do the reciprocal operation. So we're going to add the cube root of 1 minus 8 to both sides. 1 minus 8x, excuse me. And then altogether it's 3, or cube root of 4 plus 6x equals the cube root of 1 minus 8x. And then we have to take the cube root, we want to get the base by itself, right? So then the opposite of a cube root is going to be everything raised to the third. 4 plus 6x equals 1 minus 8x plus 8x to both sides minus 4. So now we have 14x equals negative 3 divided by 14. X equals possibly 3/14, negative 3/14. So now we have to check our answer for true or false. We want true. So x equals negative 3/14. It's going to be cube root of 4 plus 6 times negative 3/14 minus the cube root of 1 minus 8 times negative 3/14. Both of those will equal 0. So this is, in your calculator, 1.39 minus 1.39. These are approximate. Equals 0. So 0 equals 0. This is a true statement. So this is your solution. Circle of 1/4 is going to be 4/1. So you're going to multiply both sides by 4/1. But you're going to have to move the 3 over to the right-hand side before you do that. So it's only the base of x plus 4 that's raised to the 4th power. I'm sorry, to the 1/4 power. Again, to undo this, we're going to multiply each of these by 4/1. So I'm going to get x plus 4, right? We just get the base by itself, equals 81 minus 4 from both sides. X is supposedly 87 or 77. And we're going to test our solutions. So then we're going to get 77 plus 4 raised to the 1/4 power. So that's going to be 81 to the 1/4 plus 3 equals 0. 3 plus 3 equals 0. 6 equals 0. So this is automatically false. This is an empty set as your solution. Since this exponent is positive and the index is an odd number, I'm sorry, positive 2, we're going to have to now use a positive and negative 9 as our solutions. So you have two solutions that are possible here. So it's going to be x to the 2/5 equals negative 9. And then you have x to the 2/5 equals 9. Again, all of this is happening because of this square as the exponent. So when you do the reciprocal, it's going to be 5/2. But you have to do it to both sides, times 5/2. And 5/2 is the exponent. So then it becomes x equals, let's see. X equals negative 243. X equals 243. So our solution is x is equal to positive and negative 243. We do not need to check our solution. X squared, so u squared would be x squared times x squared. So u squared equals x to the fourth. So we're going to make all of this u in the terms of u instead of x so that we can factor it. So it's going to be u squared minus 5u minus 3, 6 equals 0, u minus 9, u plus 4. Our linear factors equal 0, u minus 9 equals 0, u plus 4 equals 0, u equals 9, u equals negative 4. These are not our solutions. Now we have to undo the u substitution. So this is x squared equals 9. X squared equals negative 4. We're going to take the square root of both sides. So I get x equals positive and negative 3. X equals 2i, positive and negative 2i. So altogether, solutions for x are equal to, I will expand this for you, negative 3, 3, negative 2i, and 2i.